Good morning to Mayor Imamoglu and the ladies and gentlemen who participate in this event. The theme of this conference is a very important one, about 100% renewable energy. What I will try to do through my presentation is show you what such a pathway of transition could look like for the world. And then I want to put that into the context of the present discussion about the post-COVID stimulus package. So we think that there is now a very important opportunity through these stimulus packages to make significant progress on energy transition and to create a win-win. So on one hand, create jobs and new economic activity. On the other hand, also achieve our long-term environmental goals. Let's see if I can go to the next slide. Yeah. So if you look at the impacts of the crisis, we see a number of effects. We see, of course, that overall energy use and CO2 demand is down. On an annual basis, we don't know yet exactly what that will look like, but let's say in the order of 5 to 10%. We see that the impacts on different fuels are quite different. Renewables continue to grow. I will come to that in a moment. At the same time, we see that fossil fuel use and fossil fuel prices have dropped significantly. So the impact over the whole year is not yet clear. We've seen a significant drop towards April and May. We see now some recovery in some markets. So, but it's clear that the impacts are significant. Now, to give you an example what these impacts look like. So here I took some natural gas prices for Europe as an example. And so today's gas prices are very low. They have dropped to a level of around $2 per gigajoule or per million BTU, which is an unprecedented low in natural gas prices compared to historical levels. And we've seen also very significant price drops for oil. So the price of Brent oil has almost halved. And for coal, we have also seen some price reductions, but not to the same level as for oil and gas. The reasons for these price drops are of course not only Corona. If you look at the gas price trends, then you see that this price decline already started earlier, but it certainly has exacerbated these effects. Now, if you look at the electricity markets, the impacts are also very interesting. So I took Europe again as an example. The electricity consumption and generation is about 10% down. Was 10% down last month in May compared to the same period last year. But the impact on the different forms of generation is very different. So the renewable electricity generation increased by more than 8%, while the generation based on coal and natural gas declined between 20 and 30%. And because of these different effects, the share of renewables in total electricity generation increased very significantly to 48% last month. So nearly half of all electricity in Europe is based on renewables. So we're halfway to your objective, if you like. These effects can be explained by the fact that, of course, we continue to add significant amounts of renewable generation. So also last year, capacities added were very significant. And once you have built this capacity, the marginal cost of production are very low. So renewables have almost zero marginal cost, while for fossil fuel plant, you have to pay for the fuel. So if there is an oversupply, what will happen is that renewables continue to produce and fossil generation is reduced. And that's the effect you see now in all these markets. Now, looking at the longer term, we need an energy transition for climate reasons. For climate reasons and for also, for example, local air pollution reasons. And that will have a profound impact on both the supply and the consumption of energy. We make an assessment every year, and our Global Renewables Outlook was released in April. And we looked what is now the optimal way to make such transition and what are the socio-economic impacts of such transition. So on job creation, on economic activity, etc. And so based on that long-term outlook, then we can say what should now be the priorities also for these short and midterm stimulus packages. So that is a currently ongoing exercise we're working on. So if you look at power generation, then already for some years, the capacity addition for renewables, which is shown here in blue on the right axis, exceeds those for fossil and nuclear generation. And so the share of renewables in capacity additions is in the order more than 70%. So in the electricity sector, we are well on the way to make that energy transition. And the reason is, of course, environmental policies play a role, but the most important reason is the superior economics of renewables. And there we've seen a tremendous progress over the last 10 years. So the cost of renewable power generation have come down dramatically. And the cost declined for solar PV by 82%, for wind somewhere between 39 and 29%, depending on the specific technology. So, and because of that, renewables has become the most economic choice for power generation in most markets, and that's why we see this rapid uptake of renewables in the power sector. So we issued our renewable costing report, or annual roundup this week. It's a new report, you can find it on our website. And we, based on the cost data we collect worldwide, we did some analysis and we found that not only that renewables are the cheapest option based on levelized cost of electricity, but even if you look at the cost of new renewables versus just the fuel cost of coal plant, then in many cases today, renewables are cheaper, which means that there is now an economic opportunity to replace existing coal plant with new renewable plant and have an economic benefit. And also the environmental benefits of such a transition can be very significant. So we found that you can save about 5% of global CO2 emissions through these type of economic measures, economic today. But the power sector is only part of the transition we need. So what this graph shows is the CO2 emissions, energy-related CO2 emissions with policies in place. That's the orange line. Then you have the impact of the planned policies, notably the nationally determined contributions. It's in climate policy, so that's the yellow line. And then the blue line at the bottom is what we really need. So we need a 70% emissions reduction. And to achieve that, we need significant measures in the power sector, but also in the end-use sectors. So buildings, industry, and transport are also very important. And so we assessed what we think is the best way, the most economic way to achieve that. And our conclusion is that renewables account for more than half of the potential, but also energy efficiency is really important. So these two measures together account for nearly 80% of the total effort that is needed to be in line with the Paris Climate Agreement. And so in the power sector, we've seen significant progress, but we need even more progress. And that means that especially we need to add a lot more solar PV and wind. So at the moment we have around 600 gigawatts of wind and 600 gigawatts of PV. That needs to increase more than tenfold in the next 30 years. So this is a big market already, but it has just started. We need much more of such capacity. And that will allow us to grow the share of renewables. So this year, globally, a share of around 30% is expected. That needs to grow to 86% by 2050. And the high percentages of renewables we've seen last month, which I just discussed, show that it is technically possible to integrate very high shares of renewables in power systems. So that is a new and very important insight. So we have economic options and we have technically feasible options to transform the electricity system. And now it's a matter of rolling that out worldwide. Now, I said the end-use sectors are really important, and there we have a number of strategies that can contribute to achieving these emissions reductions in buildings, industry, and transport. And a key one is what we call electrification. So replace direct use of fossil fuels with electricity. And for example, in the transport sector, electromobility, electric vehicles are really important. In the heating sector, heat pumps, electric heat pumps are really important. There are certain opportunities to electrify industrial processes, etc. So we think that the share of electricity in final energy use needs to increase worldwide from around 20% today to 50%, so half of final energy use by 2050. That is really important. It cleans up the end-use sectors, because electricity has no direct emissions. And if you produce that electricity with renewables, there are also no upstream emissions. And at the same time, the use of electricity increases the efficiency very significantly. So an electric vehicle has 2-3 times the efficiency of an internal combustion engine car. A heat pump has 3 to 6 times the efficiency of a conventional fossil fuel boiler. So there are significant gains to be achieved. And at the same time, you clean up the air in cities, for example. So we just heard about Istanbul. Electrification can really play an important role there. Now, a new element is, apart from direct electrification, what we call indirect electrification. So there's now a lot of attention for using renewable electricity to produce, for example, green hydrogen through electrolysis. And then use that green hydrogen to produce other energy carriers. So you can use green hydrogen to produce methanol, to produce liquid fuels, to produce ammonia. And then you can use these energy carriers in specific applications, such as aviation, such as shipping, such as heavy freight transportation. So that's where now a lot of the effort is focused. Now, this is a complicated graph. It shows the overall energy transition. So split in different steps. So first, the transforming energy scenario gives the 70% emission reduction. Then we looked at ways to get even to zero emissions by 2050. That's what we call the DDP here. So that is the pathways for zero emissions. And if you look at the bottom bar, you see the overall contribution of options. So renewables important, energy efficiency important, electrification really important, both direct and indirect through the use of green hydrogen. So together, these options represent about 90% of the effort. And the good news is, as Professor Uyer explained, that we see that the benefits exceed the cost by a factor 3 to 8. So there is, from a policy perspective, also a very strong rationale to go for these solutions. Now, I come to the link to the transition to the stimulus packages. So, and the key point is, of course, what does this now mean for investments? So let's say the planned energy scenarios would result in energy investments of around 95 trillion between now and 2050. If we go for these transition pathways, we need investments between 110 and 130 trillion dollars. So that is a very significant amount. It's an increase in the order of 20 to 35% compared to this reference case. It's also a significant increase of investments, and the share of investments across different energy categories is very different, with a much lower share of fossil fuels, much higher share of efficiency, renewables, and electrification investments. So, and this is an important opportunity, and we can start now with these investments, as I explained earlier. So we can use this opportunity for the stimulus packages. So 2050 is far away. What we're currently doing is we're looking at what does it now imply for the next 10 years? What are the opportunities to 2030? And what we find there is an investment need of nearly $60 trillion worldwide between now and 2030. And we would need annual clean energy investments into renewables and efficiency, electrification, of around 4.5 trillion per year. So we're talking about trillions of investments that could be that will be done under the stimulus packages, but we also need trillions of investments for this energy transition. So if we can use the stimulus package for these investments, we can create a win-win. We can create new jobs, we can create new economic activity, and we can make the energy transition happen. And so what are the economic benefits? We see a potential to increase global GDP by 2.4%. And we see that the cumulative additional economic activity created for the next 30 years because of investments starting now would be in the order of 100 trillion. So these are very significant effects. And if you look at the job creation potential, so the total energy jobs at the moment are around 60 million. We see a potential to increase that to around 100 million through energy transition, and the jobs in renewables would increase nearly fourfold to around 42 million by 2050. So there is a significant opportunity to create jobs and economic activity through energy transition investments, and the stimulus packages could be used now to put this into practice. And we see that the if you look at the jobs as an indicator, we see that there is a worldwide potential to create jobs through this transition. So it's a global win-win to consider these investments. So in conclusion, we need a significant energy transition for environmental reasons. There is a compelling economic case now to make this happen, and we can create a lot of jobs. We can create increased energy security and higher energy access through this transition, and therefore we argue that this energy transition investments should be an important component in the stimulus packages that are currently being put in place. That concludes my remarks. Thank you very much for your attention.
So yeah, I want to talk about energy plans that we've been developing